No, go ahead. All right. So we just make up two vectors, x and vector y. And if you use graph paper, you can get the vector where we have x, vector x plus vector y right away from the graph. So if we do vector x plus vector y, then we have resultant vector will be from initial point of here to here. Okay. So then if you look at the graph, you can tell right away what is the component form of vector, the resultant vector of x plus y. Can someone give me the resultant, the component form of resultant vector? Okay, my question again, can someone give me the component form of the resultant vector x plus y? So from initial point, how many units did you move? And first, do you move to the right or the left? Thank you, Trung An, for trying. Anyone else? Okay, I already got 8, negative 3. Trung An got 3, negative 7. Anyone else? Saskia got negative 8, 3. Trung An got 3, negative 8. So component form come from x, y, right? And x means how many units you move into the right or the left from the initial point to the terminal point. And y means how many units you move up or down from the initial point to the terminal point. So then from the initial point here, you go to the left 1, 2, 3, 4, 5, 6, 7, 8. 8 units. So therefore component form will start with negative 8. And from there you go up 3 units to get to the terminal point. So therefore it will be 3. So component form will be negative 8, 3. That's how you use the graph to do it. If you want to do it algebraically, remember yesterday we talked about this, how we find the component form of the resultant vector. So to get negative 8, I will have this negative 8 come from negative 5 minus 3. And this 3 come from 8 minus 5. So here, let's do it. Move it down here, and I change it to x1, y1. And this you can think about as x2, y2. So the formula to get the resultant vector will be x2 minus x1, y2 minus y1 as a component form. All right. So if you still confused about how to get the component form for the vector resultant vector, you should put down the formula somewhere. All right, now the question is, if you have magnitude of vector x plus the magnitude of vector y, will it equals to magnitude of vector x plus vector y? Okay, so in order to do that, I'll do two of them separately. So first of all, I already saw a few of you calculate the magnitude of vector x and vector y. So go ahead and give me the answer, okay? So for vector x, what is the magnitude of vector x? Okay, magnitude of vector x. Anyone got the answer already? Okay, Saskia, give me 5.831. Can someone confirm? Lynn got 5.8. Thank you, Sean. Thank you, Lynn. Thank you, Saskia. So 5.83. All right. And I just want to show work to make sure you guys got it right. So basically for the magnitude, we will take the component from here, which is 3 square inside parentheses plus 5 square. And we get 9 plus 25, and this give you 30. Wait, hold on. 34. Wait, stuck with my stylus. Okay, square root of 34, and it's approximately equals to 5.83. Okay, that's how we get the magnitude. All right, very quick. I don't show work anymore for the magnitude of y. So someone give me the magnitude of vector y. Okay, Saskia give me 9.4. Anyone else? Sean got 9.43. Okay, so I guess it's 9.43. We can rely on you guys. Okay, and using that means now I have down here I use a plugin here, so 5.83 plus 9.43 for the left side. And what do I get? So I put a question mark up here. Okay, thank you. So we get 15.26. Thank you, Ivory. Thank you, Lean. All right, now that's just the left side. For the right side will be totally different, okay? Because we cannot take those and add up just like the one we just did. But in fact, we have to find the magnitude of the resultant vector, which is x plus y, like this. And the component of resultant vector is negative 8 comma 3. So therefore you have square root of negative 8 square plus 3 square. And we have 64 plus 9, so this will be square root of 73. Okay, what is square root of 73? Turn it into decimal. Thank you, Aiden. So 8.54. Thank you, Saskia. So we get, on this side, we get 8.54. Are they equal? No. Yeah. So hopefully we all know that the magnitude of each vector add up together not equal to the magnitude of the resultant vector. Okay. All right, did I confuse anyone at any step? Time to process the new information and ask me question. Right, no question at all. All right.